So we're going to the end of the chapter, to section 4.8, and then we'll come back to 4.3. 4.8 deals with isosceles triangles and equilateral triangles. I thought that that fit well with what we had just discussed because we were doing the naming of those shapes. Isosceles means what? What about two? At least two sides congruent. And equilateral means all sides congruent. Okay, so those are the definitions. We usually use isosceles to mean two, but the definition is a little bit different than how we use it. Okay, so some things related to isosceles triangles and vocabulary. We might have talked about some of this related to that first section. So perhaps a little bit of repeat, but I think there's some new terms here that we didn't already talk about. It says, recall that an isosceles triangle has at least two congruent sides. The congruent sides are called the legs. We did talk about that. Vertex angle, I don't think we discussed that yet. The vertex angle is the angle formed by the legs. So in the picture that's up here, would angle 1, 2, or 3 be the vertex angle? Which one's formed by the legs? Jaden? Angle 3, correct. Angle 3 is made up of the two sides that are congruent, and those are the legs. So that's called the vertex angle. The side opposite the vertex angle is called the base. So that side, that's another way to describe which one's the base. It's across from the vertex angle. And then the other two angles, the angle 1 and 2 that are highlighted, are referred to as base angles. Base angles because they are, one side of it is the base of the triangle. So angle 2 is formed by the base and this leg. Angle 1's by the base and the other leg. So those are the two base angles. So two base angles, one vertex angle. The two theorems related to isosceles triangle talks about the base angles and the sides. I know you have to add some words there. The first one is called the isosceles triangle theorem because you need an isosceles triangle to use it. So the hypothesis is if two sides of a triangle are congruent. So in other words, if the triangle is isosceles, then the conclusion, the angles opposite the sides are congruent. Two sides are congruent when you go across the triangle to the angle from each side to across the triangle. Those two angles are congruent. The converse is in the complete reverse order, and it's also a true statement, so that's why now we have a converse of this. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So as you're doing your hypothesis and conclusion, what's the difference? What's the hypothesis of the first one? Triangle with two sides congruent. The hypothesis of the second one is a triangle with two angles congruent. So to decide which you're using, pay attention to what do I have for the hypothesis? What do I have in the problem to start with? If you look at that first theorem, if angle B and C are congruent, is angle B the vertex angle or a base angle? Would angle B up here be a base angle or a vertex angle? Is it formed by the two congruent sides? Nope, it's not formed by the two congruent sides. It's a base angle. It's formed by a leg and the base. So angle B is a base angle. How about angle C? What's it formed by? Formed by the base and the leg, so it's a base angle also. So in other words, these two angles are the two base angles, that are congruent? Sometimes this theorem is stated just that the base angles in an isosceles triangle are congruent. That's saying the same thing. A is the vertex angle. So if you would fold it right through angle A, the triangle would be symmetrical. The two halves would match. So that might help you visualize which sides and which angles are congruent. So on the second one, if I would fold the triangle so that those two angles matched up, the DE and DF would be the sides that are congruent. The theorem describes it as, if you go from angle E across the triangle, DF is one of the congruent sides, and then from angle F, go across the triangle, DE is the other congruent sides. So it described going opposite in the triangle. So I mentioned this, you could say just base angles of an isosceles triangle are congruent. So let's do a practice problem or so. Find the measure of angle F. It's an isosceles triangle, so that theorem works. Two angles should be congruent, which two? Think about folding it. Angles D and F are the congruent ones. We don't know either one. But we know the vertex angle is 22. And we know from yesterday, the triangle sum theorem, what should all angles add up to be in that triangle, Brendan? 180. So how could we find angle F? Molly? How can we do this one?
Subtract 22 from 180 and then divide that number.
Okay, so calculate it. So subtract 22 degrees from the total of 180, and then divide that remaining total in half. What do we come up with? So I was kind of asking if it was in this as well. All right, what's it calculate to be? 70, how much? 79. 158 divided by 2. Okay, question on that one. All right, next one. Still an isosceles triangle, but I gave you some different angles. Find the measure of angle G. Theorem says if it's an isosceles triangle with two sides congruent, there's going to be two angles congruent. Zach, figure out which two they are. This one you really don't need the triangle sum theorem because the two angles that you're given are the two that need to be congruent. So you need the x plus 44 and the 3x to equal each other. And tell your partner what you came up with.
66. Yep.
X was 22, but the angle was 66. I heard quite a few of those. Did you set it up right? Set those equal? No. You're adding, okay, these two angles are not going to add up to be 180 degrees. If you're adding to 180 degrees, Paige, you would need all three angles in the triangle. Are these two a linear pair, class? Are these two a linear pair? No. What was a linear pair looking like? Linear pair, they had to be adjacent. They had to be at the same vertex, angle 1 and angle 2. That would be a linear pair. When they have different vertices, there's no way they're going to be called a linear pair. All right, let's try another problem. I think that says 48. Find the measure of angle F. That's 48 degrees. Which two sides are the congruent, or which two angles, I should say, are the congruent ones? G and H. G and H should be the congruent angles. So if G is 48, H is 48, and then the other one is different than the other two. So. Okay, angle should be 84, triangle F, how many got it right? All right, if you got tricked, you probably didn't use the correct ones as equal. And how about another one with variables in it? Which angles are the congruent ones? About folding it. Okay, Ann, share with your neighbor.
I know. I wonder if that's your different.
It's completely
All right, got it correct? Isosceles triangles, think about folding them, that might help you match them up. And the converse starts with what? What's the hypothesis to use the converse? Is it the angles that are equal or the sides that are equal? The angles are the hypothesis part of the converse. The sides being congruent is the isosceles triangle. I think there are a few problems that might ask you to support it. This was just a where would I use this? If yx is 20 feet, explain why the length of yz would be the same. Why would yz have to be 20 feet? That's my guess, Abby?
Well,
Because if you're gonna find angle Z, I think it is,
Angle YZX,
Yeah,
this one.
you take 180 minus 140, and it'd
There's
be
a linear pair. Okay, so 180 minus 140 is 40.
degrees. And then since those angles are congruent, then the sides have to be congruent too.
According to
The isosceles triangle theorem. Converse.
converse, because you're starting with the angles and getting the sides congruent. Correct. All right, let's look at the ideas about equilateral and equiangular triangles. So this is really an extension of the isosceles triangle theorem and its converse. But what happens when all three sides are congruent, or three angles congruent? So these are corollaries, and we said yesterday corollaries are theorem ideas that you can easily get from a previous theorem. So these come right from that isosceles triangle part. If a triangle is equilateral, then it is equiangular. So if it has all three sides congruent, then it will have all three angles congruent. And the bottom corollary, they named equiangular triangle corollary instead of converse of, because it kind of helps you remember better what the hypothesis is. If a triangle is equiangular, then it's equilateral. If all three sides are equal, all three angles will be congruent. If all three angles are congruent, then all three sides will be the same. How can you get those easily from the isosceles triangle theorem and converse that we just did? Well, if you would concentrate on two sides at a time, you can apply those previous theorems. So if I would concentrate on AB and AC as my congruent sides, according to that isosceles triangle theorem, the angles that would be congruent would be angle B and angle C. Then with those congruent, I'm going to switch my focus on AC and BC as the congruent sides. If these two are congruent, wouldn't angle A and angle B have to be congruent? And if angle B is already marked that way, angle A's got to be marked the same. So I do end up with all three sides congruent and all three angles congruent. Same thing can be done on the bottom one. So if you just pair them up, you can apply the previous theorem. Anyone still need the screen? You see how the names make it easier for you to know which one you're using? Was it an equilateral or was it an equiangular to start with? Okay. All right, so find the value of x. Are we using the equilateral corollary or the equiangular corollary? What do we have in the picture? Equilateral. Okay. So it said if it's an equilateral triangle, then all angles will be congruent and be equiangular. So all angles have to be congruent. How do we figure out what x is? Probably two different ways. All angles are the same. So if that one's 2x plus 32, and the is 2x plus 32, and then the is 2x plus 32, and yesterday we learned that all three should add up to me. There's two ways to do this problem. So if you're stuck, here's some thinking. If you're not, go right ahead. If it's equilateral, then the corollary said it's also equiangular. So all three angles are the same. So that angle's 2x plus 32, this one's 2x plus 32, and this one's 2x plus 32. Yesterday we learned what all three angles should add up to be. So add those three, and it should said equal to 180. We also had something else that could make it a lot quicker to do. I think yesterday we had a equiangular measure corollary that told us what's the measure of each angle in an equiangular triangle. If all three total 180 and they're all the same, each one is 60. So another way to do this problem is take one of those angles, 2x plus 32, it has to equal 60. Is that right? What's x come out to be? So I did the 60 idea. But we talked about doing the 180 idea. And give me a thumbs up or down. Did you get it right? Or understand it? Okay. Seeing just a couple kind of iffy. Here's another one. Get rid of my scribbles. Now this one starts with three angles congruent. So this is really the equiangular corollary. Said if all three angles are congruent, then the triangle is equilateral, which means these sides have to be the same. I gave you two of them. How long are the sides? All sides are equal. Confer with your partner. I'm going to have a 180 in this problem because as you look up there, did I give you angle measurements or side measurements? Notice I gave you side measurements. It's not the side lengths that have to total 180 degrees. The angles have to add up to 180. So what you need to do on this one is go 2t plus 1 has to equal 4t minus 8. All right, did we get it right?
I don't know.
A few errors. And I think some of you were stumped thinking, okay, I don't have kj at all. But if all the sides are equal, as long as we can find one of them, we find kj. So substitute into whichever side you want, and you get 10 for kj also. All sides equal 10. Okay, hop up and touch two walls while I switch my PowerPoint. Touch two walls and have a seat. It's bright. Okay, the lesson that we're gonna combine with this is on 4.3. So flip back to 4.3. We're gonna simply talk about what does it mean to have completely congruent polygons in triangles. We're gonna use the term corresponding angles. We had those with parallel lines in the transversal, but this is a different meaning of corresponding. It still kind of means matching, but they match in a different way. Okay, so some of the definitions at the top there. Says geometric figures are congruent if they are the same size and shape. So congruent figures are basically identical. They might be flipped or turned a different way, but they're the same size, same shape. When you have them matching up, you have corresponding angles and corresponding sides. So those are basically the angles that match up and the sides that match up. When I say same position, it's kind of hard to describe that because it might be that it was turned, but like in the same order or arrangement in the two triangles. And for triangles, you can't really arrange them a lot of different ways, but basically they're in the matching spots in both triangles. Or polygons. I say you have to compare polygons with the same number of sides. You're never going to get a square congruent to a pentagon. There's no way they're the same shape. Same with a pentagon and an octagon or something. Two polygons are congruent polygons if and only if their corresponding sides and corresponding angles are congruent. So we've got to have all parts matching, same size, degrees, lengths, in order to get them congruent. And it says at the end, thus triangles that are the same size and shape are congruent. Here's some details for you. I gave you which part? I didn't give you the diagram. Okay? I gave you all the written out stuff. So you are drawing congruent triangles and then congruent rectangles, basically. I didn't go to 10 sides or something like that because it just takes too long to draw it. But what you are drawing and marking are the congruent corresponding angles and corresponding sides. So angle A is congruent to angle D. So you need angle A and angle D marked the same. Angle B is congruent to angle D. So mark those the same but different from the first pair. And then angle C and angle F are congruent. 3 and 3 is what I did. So you've matched up the angles. And then if you match those angles, the sides should match in the same way. So just to double check, your tick marks. Segment AB should be tick marked the same as segment DE. Segment BC marked the same as segment EF. And segment AC the same as DF. Now before I talk about the quadrilaterals, did you notice, or would you notice this part, please? Okay. Triangle ABC is congruent to triangle DEF. The order that this is written is very important. You can write down the first triangle whatever order you want, ABC. But then when you list the second one, you have to list the order they match. When you're using congruence, you have to list how they match. So I wanted A to match with D, so D had to be listed first, and B matched with E, and C matched with F. So this statement tells you the angles that match. It also tells you the segments that match. AB, the first segment in my list, would match with DE. Segment BC would match with EF. And then CA would match with FD. So we're gonna have to be careful when we write that congruent statement because it does tell you the order that they match. Okay, the rectangles actually could match in more than one way. And notice when you name any kind of a shape, you have to go around it. You cannot jump across it. So I went PQRS and then WXYZ going around it. All the angles are 90, so that's not a big issue. Side lengths. I want to make sure that PQ matched with WX. One tick mark, yes. The next segment would be QR. It has 2 tick marks. XY has 2 tick marks. Correct. So on a quadrilateral, you've got 4 pair of angles and 4 pair of sides. So if I had given you a 10-sided polygon, how many pairings of angles would there be? 10. And how many pairings of sides would there be? 10. So you'd have 20 things to list. So I didn't think I needed to do that. I thought you did the idea with 3 and 4 sides instead of going huge. Are we getting done with the pictures? And notice the statement down here. I just put polygon, PQRS. There is not a separate symbol for rectangle or pentagon or octagon. There is for triangle, but other than that, we just write it with polygon. Sometimes we even get lazy and don't write that word. Ready to go on? Next slide. Okay, so I emphasize this. When you write the congruent statement, you are stating which parts are congruent. So here's something that students don't maybe remember. Definition of congruent polygons. Up at the top of your notes it says that polygons are congruent when all the corresponding angles are congruent and all the corresponding sides are congruent. That definition is what we would use to come up with congruent triangles or to get all the separate parts listed. So in order to use that definition on triangles, you do have to come up with 6 things. You've got to get all the angles congruent, you've got to get all the sides congruent to say the triangles are. We're going to do that. Okay, first I want to see if you can give me the corresponding congruent parts. Okay, I'm giving you triangle PQR is congruent to triangle STW. Can you list the 6 corresponding congruent parts? The 3 pairs of angles, and 3 pairs of sides? Try and use the correct symbols, telling me what is congruent to what. What supports everything you're listing? Definition of congruent polygons. If you want to say definition of congruent triangles, that's fine. You're naming what specific polygon it is. Okay, you came came up with, my segment symbols are a little bit off there, but those 3 pairs of angles and those 3 pairs of segments that are congruent. Is segment PR the same as segment RP? Yes. Segments, you can reverse the letters. It was Ray's that the order was important. Any question on just listing those, matching them up? Okay, so if so, I'm gonna, or if you don't have questions, I didn't have another example. I think I already talked about that. Go around the shape when you name it, like PQRS. Don't jump across it and go PQSR. That doesn't work. All right, and this one just had the 4 angles and 4 segments. So if you got it with 3, we'll skip the 4. This is a type of problem that we'll need to do. Given triangle ABC is congruent to triangle DEF, what's it telling you by that first part in the information that's given? Okay, they're congruent, they're identical, same size, same shape, and it tells you how they match because of the order. Find the value of X. So X is on side AB. Okay, so segment AB is supposed to match with segment DE. DE is 6, so the 2x minus 2 has to equal 6. So you can pick that out by the order that they matched up. And I solved it for you because it was kind of quick and easy. And how about finding measure of angle F? Angle F is supposed to be congruent with angle C. I didn't tell you angle C. Can you figure out angle C?
Yeah.
Should be able to based on what we did yesterday. What should the 3 angles in the triangle total? 180. So subtract the 90 and the 50, so take off 143 total. Angle C is 37. So angle F is 37 degrees. So see what matches and use things that we've studied to help you out. All right, let's do, I'm going to skip a couple. Let's do a proof. Write down in your notes the solution to this proof. We're going to try and prove the 2 triangles congruent. And all we have today to use is the definition of congruent polygons. So we have to get all 3 pairs of angles congruent. We have to get all 3 pairs of segments congruent. Then we can say the triangles are congruent. So we've got a few things we need to come up with. But I think you can do it with me. Preference on the format, flowchart, 2-column, paragraph. 2 columns good enough? Okay, 2 columns. We need to come up with sides that are congruent and angles that are congruent. And I don't care where we start. Who wants to give me a beginning idea to go with? John?
AD bisects BD.
Okay, segment AD bisects segment BE. Where did you get that? What's your support? Given. Okay, let's focus on that and see, does that give us any segments congruent or angles congruent? What's it mean if segment AD bisects segment BE? BE is cut in half. So what segments are congruent? BC and CE? Okay, I better put 2 tick marks there. Okay, so segment BC is congruent to segment CE. Tina, what's your support? Not midpoint, it didn't say midpoint. Okay, definition of segment bisector. And off to the side here, I'm going to just put S. That's a pair of sides congruent. We've got 1 out of 6. Let's get going. Sam, give me the next thing you want. Okay, segment BE bisects segment AD. Where'd you get that? Can we come up with something, either segments or angles that are congruent based upon that? Riley? What segments or angles would be congruent based on that? If we are bisecting segment AD. AD is getting cut in half. So what two segments? Okay, segment CD, AC are what? They have to be congruent because it's bisecting. What's her support? Okay, that same definition of segment bisector. I'm going to put an S out there, that's another pair of sides. Okay, so I got those, I got these. I wish I wouldn't have put those first tick marks up there, but let's keep going. Number 5. What do you think comes next? Kristen? What do you want to put next? Have we used up all the given? No, so give me something more. Okay, angle A is congruent to angle D. That was given. And that's already marked in the picture. I'm going to put an A because that's a pair of angles. I don't think I'd do anything more with that. Number 6. Steven? Segment AB is congruent to segment A or DE because given. Those are the tick marks that were up there originally. We got the sides all done. Got one pair of angles, let's get some more angles. Are there some more angles that are congruent? And do we have a reason for it? Okay. Angle B, you said? Give us support. He's going with angle B and angle E and searching for support. Is there support why those two are congruent? I know some of you are thinking alternate interior angles. Right? Are the lines parallel? No, can't use it then. We don't have the hypothesis, so you can't use that theorem. Which one? Is it an equiangular triangle? Is it an equilateral triangle? No. I think we're going to get stuck. Yes.
Angle BCA and angle BCE are congruent.
What?
Vertical angles.
Is vertical angles theorem good? He's saying this angle is congruent to this one by the vertical angle theorem. Yes, we haven't used that maybe just lately, but we need to use it now again. So another angle pair is angle BCA congruent to angle DCE. And he did vertical angle theorem. Now let's go back to what Paige was trying to do. Angle B congruent to angle E. There's a theorem we did yesterday that will help us. We have two triangles. There's two angles in one triangle congruent to the same two angles in the other triangle. Pretty sure it was yesterday. It is the third angles theorem. What's the conclusion? Then the third angles are congruent, which now, in the order we did things, that would be the angle B and angle E. So third angles theorem supports what Paige was trying to do a little bit earlier. Now notice according to my list, we have all 6 things that we need, the 3 pairs of angles, the 3 pairs of sides. So now we can say the whole triangle, ABC, is congruent to triangle DEF, or DEC I mean. What's our reason? What says that all corresponding angles and sides makes congruent triangles? Definition of congruent polygons. Definition of congruent polygons. You want to put, I will probably say definition of congruent triangles, but because the triangles are a special polygon. Okay, that's a proof based on what we're doing. So I think there's one of those for you to do, maybe filling in parts of it. I don't think you're doing it from scratch. So we have a few minutes. We've got 5 minutes today. Page 276 is where you'll start. So don't close up and the first page that I wrote down is 276. That's the section we did first where we were doing the isosceles and equilateral triangles. And then 234 is the section we just ended with where you were doing the congruent corresponding parts, the congruent polygons. I don't care which one you do first on your assignment, but just label which one it is so that when we check it, it's easy to know. Pick which one you're going to start on, and let's get a little bit done.